And we are live. Hello, good day, everyone. My name is Herns Hermida. I'm the Azure Business Lead of Microsoft Philippines. And today's webinar is going to be about running DevOps and DevTest on Azure. So we're going to give you an overview of all of the DevTest options and tools that you have on Azure, as well as discussing the basic of DevOps and how you actually run DevOps on top of the Azure platform, and also GitHub. Just a few reminders before I start the actual content of this webinar. I would like to give full disclosure that we are conducting this webinar from my house. So my home is not exactly the most soundproof home in the world. So you are going to hear, unfortunately, some background noises, both natural noises like dogs barking, birds chirping, wind blowing, and some unnatural noises as well, such as people talking softly in the background and dogs and doors, doors banging, cars passing by. Unfortunately, we're in all of this situation of enhanced community quarantine, so I do apologize in advance if you hear any of these things. I'll try to be as clear as possible as far as delivering my voice is concerned. I'll try to be as clear as possible. If at any point it becomes too noisy in the background, I will pause. I will pause and turn on the mute button so we won't be disturbed, and then resume as quickly as possible. A couple of reminders as well. This entire webinar is recorded, so you can you can catch the recording of this entire webinar once you get an email from us within 24 to 48 hours of time. The slides of this webinar will unfortunately not be available to you for download, but this entire webinar will be available to you for listening in a recorded fashion, as via a recording on demand. And if you have any questions during the conduct of this webinar, you can definitely post it up in the Q&A box in your webinar interface, and we'll try to answer them as much as we can. All right, once everything is clear, let's start. Okay, so I want to start this webinar by showing this slide, that the fact that there is a massive disruption that is happening to every industry today. That is called digital transformation. So in order for digital transformation to be successful in every relatively large company, every company is becoming a software company. What does this mean? Becoming a software company means that companies are starting to develop their own solutions, develop their own software, as well as maintaining and enhancing software that they have bought from other vendors. So therefore, developers at the heart of every company's innovation, especially if you have your own pool of developers that drive your digital transformation by coming up with new or enhancing your existing applications. And in order for your developers to drive this innovation, they would have to increase their productivity, and we have to make sure that we accelerate collaboration amongst developers within the company as well as outside the company. Product innovations need to reach the customers quickly and stay available. So think of your favorite app on your phone today. Say, for example, something that was useful before, which is Waze, but now it's not quite useful because almost everyone is on quarantine. But you would expect that your Waze app should always be available all the time. And if there are any updates on your applications, that actually happens on the fly. You don't even notice that that the Waze application has already updated over the background, and you just notice new updates whenever you turn on the application every time you need it. So these innovations, this is an example of an innovation that reaches you quickly and becomes available. You have to accelerate delivery as well as optimize the reliability. There are three powerful trends that affect this new wave of digital transformation driven by our developers. First, this is one of the obvious things, which is there is an insufficient supply of developers. There's just simply not enough developers out there. And even if you have enough developers, the tool sets that they use are quite disparate. They have different preferred tools of developers. You have one side of purely open source developers, and you've got open developers who are purely into Visual Studio and Microsoft Stack, and you have people in between. 99% of all code bases include open source. So there is the concept of originally written software line by line almost do not exist nowadays, because developers nowadays reuse a lot of code that was created by a lot of developers, shared over sharing platforms such as GitHub, for example, and most of these are open source. And a majority of companies are struggling to develop to adopt DevOps, and we'll talk about what DevOps is a little bit later. All right, sorry for that slight pause over there. I just had to make an adjustment on my audio. It seems to be picking up a lot of background noise, so I just turned up the noise canceling, and I hope this sounds better. All right, now, what is DevOps? I'm using this slide to illustrate and discuss to you what DevOps actually means. As you can see there in the middle of the slide, it is actually a continuous cycle of planning for software, developing the software, delivering the software across your delivery channels, operating, maintaining, and running maintenance on the software itself, and then the cycle continues from planning, developing, deliver, and operate. As long as the application is still active, you continue to do that to all the steps related to planning, developing, delivering, and operating updates to the software. This will also require collaboration, a workflow engine in order for your developers to collaborate effectively, security and compliance measures to ensure that your code remains bug-free and also free from any security risks, and also continuous improvement while the application is running. Assuming it is a popular application, more and more users will be running it, and you will be adding more features, and therefore improvements need to be considered over time. Because of this simple cyclical approach to application development, it has resulted to 30 to 50 times faster deployment cycles of applications. So instead of waiting for months or even a year for new versions of software to come out, you actually come up with newer, smaller versions of the software more frequently. Users don't even notice it because they continue to run the application, and they only notice the new features once you release them in a minor fashion. There's also a 21% increase in new software and services delivered, and average ROI of continuous delivery investments continues to increase. So great story about DevOps is one example is one large insurance company in the States called Geico. You can read the case study when you go to the Microsoft case study website. So they've said that with DevOps and running DevOps on Azure, they will be able to reduce their new feature release cycle down to 1 week. They can even speed this up because of the nature of their application, their Geico insurance application apps that run on mobile phone and also on the website needs to be updated frequently, and therefore the DevOps approach is the one that works best for them. So why do companies decide to go to DevOps versus the traditional waterfall method, if you will? And you can see here both business benefits and technology benefits. Let's go to the technology benefits first. It results in more frequent and more stable releases because part of the DevOps process is continuous monitoring and improvement of the application that you currently have out there in production. Over time, once you perfect the process and once you perfected the timing of the releases, if you will, it will be your delivery pipeline becomes more frequent and the application becomes more stable. You also experience lower change failure rates because the amount of changes that you put in are actually smaller in terms of number of units compared to large or big chunk of changes that you would do in a typical waterfall model. Also, which means that in the case of a failure of a feature or a set of features, you can always roll back to the previous version without much differences to the application, which means it's faster mean time to recovery. You'll also enable a faster, more collaborative, and more empowered development team. As for business benefits, it allows for the business to become more flexible and you appear to become more agile in front of your customers. It also allows you to become more innovative and continuously innovating the products and services that you offer out there. And it also gives the business the ability to replace elements in the value creation chain that when something better comes along or when something is no longer relevant, you can just simply add it or remove it respectively without being locked into past technology choices. So you're not stuck with the features of the application that you've just created 10 years ago, because you continuously update it using the DevOps process. Now, what do you need to implement DevOps process? So taking the software and the applications and the underlying platform required to run DevOps. DevOps essentially, remember, brings together people, processes, and technology by automating, the keyword here is automating software delivery to provide continuous value to your users. So you probably heard of the term CI/CD. CI means continuous integration. This means you improve software development quality and speed, and you build apps. CI/CD or continuous integration usually works best if your application is cloud native or built for the cloud. such as, for example, in Azure. Continuous delivery means that you ensure the code and the infrastructure are always production deployment state, and you combine integration and infrastructure as a code, you will achieve identical deployments and confidence to deploy production anytime. So the continuous delivery cycle essentially means that you have a consistent way of delivering updates to the application over time. And continuous deployment is another definition of what CD means. You can automate the entire process from code commit to production. So the underlying infrastructure that enables your DevOps allows you to automate everything from commitment to code to all the way to production, all the way to monitoring. But the reality is, in the organizations that you're working for, most likely you're working in silos. You have a different set of developers that develop. You have a set of developers, and each one is developing some aspect of the code. And rarely do they actually collaborate and share code amongst each others. So silos prevent collaboration. So internally and across DevOps team, and also it also isolates you from the open source community, which is again a rich source of innovation across application development. So I was having a conversation with one of the banks, for example, and one of the things that they've decided to do is to cut off their developers out of the internet entirely. They can't do anything. They can't send out email. They can't send out email outside of the company, outside of the bank. They cannot even download code. They cannot even go to GitHub or anything like that. It's just that's just one example of, if I was the CIO of this bank, I would second guess why I am taking this approach of essentially not allowing my developers to collaborate with anyone outside of the bank. Um, outside the or even download open source code if it's going to help the digital transformation of the organization. Now, like I said, innovation of DevOps relies heavily on collaboration. A majority, 99% of apps or with greater than 1,000 of lines of code makes extensive use of open source. Rarely do developers nowadays create code from scratch. It's a mishmash in a combination of different types of code from fellow developers within and also outside of the organization. 90% of all new codes develop application development leverages open source software. So this is where, for example, GitHub comes in. That's why GitHub is becoming the most popular collaboration and open source code platform in the world today. So speaking of GitHub, even the largest software companies such as SAP, for example, are using GitHub. The natural thing for them is to contribute back. So the developers of SAP are putting on the open source mindset. So while they are creating applications and products that will eventually end up in SAP's product portfolio, they are actually getting some of these code from open source, and because of the open source agreement, if you will, you have to contribute back. So those are the things that even large companies such as SAP are currently doing. Now, when we talk about open source and cloud, it requires an additional focus on security. And a lot of people get nervous when you talk about open source and cloud because, you don't, people will say that we don't know where these source codes come from because they are in fact open source, and a majority of them are actually created from anonymous sources. So we have to also realize that 85% of code bases have components that are more than four years old, and 60% of code bases contains over at least one vulnerability in 2018. So part of your DevOps toolchain, if you will, that you will need to apply to implement DevOps CI/CD within your organization, you must have integrated security embedded in those so that code-to-cloud workflows take into consideration security as well. Coinbase is one of Microsoft's customers, and they have used a combination of Azure DevOps and also used a combination in combination with GitHub. And they are one of our biggest customers on GitHub, and they've said in a quote, and you can see here that almost everything that they do as far as code is kept inside GitHub Enterprise, from security control to application code to internal policies. We'll talk more about GitHub in other slides little later on. So, okay, here you go. Sorry. GitHub is the #1 developer community on the planet. So think of GitHub. I like it when someone mentioned that GitHub is like the Facebook of developers, because this is where developers post their latest applications, their latest code. They share code amongst each other. They contribute code and so on. So it's based on open source Git, and the hub part comes with the hub part is the social aspect of GitHub. If you're listening to this webinar, most likely some of you, or if not most of you, are actually holding GitHub accounts. I'm pretty sure that most of those GitHub accounts are using the free free GitHub access. It has the most developers. It has the most repositories. Over 100 million code repositories are currently there. Among all of the similar platforms in the internet today. It also has the most contributions among the 36 million developers of 1.1 billion contributions in 2018. And it also is the most secure, because the community itself, and part of the GitHub capability is to issue vulnerability alerts on the code that is submitted on GitHub. And we have found about, and the platform has found about 5 million of them. GitHub unleashed innovations when it first came out, because it brings together what I like this term, social coding workflows into the organization. So if you adopt GitHub practices, you are essentially adopting DevOps, because you're unleashing the capabilities for your developers to collaborate amongst each other using the GitHub platform, for them to share code, for them to update each other's code, to work on top of others' code, so that you produce the application that you require. So this includes expertise sharing. Oh, by the way, GitHub does not only just share, it's not just a platform to share code, but also documentation as well. Uh, Other than expertise sharing, it's also cross-team collaboration, code reuse, velocity, and secure workflow. Now, in 2018, we have acquired GitHub for $7.5 billion. The GitHub company is now part of the Microsoft family, but it continues to remain as a separate entity. So you can still continue to, for example, develop applications on other cloud platforms such as AWS, GCP, or even your own internal application development platform, and still continue to use GitHub. There have been no changes in the GitHub operations and the way GitHub operates even before Microsoft acquired it. So you now have a very powerful combination of Visual Studio. So what do we bring to the table? A combination of Visual Studio, which is the world's #1 developer tool, the world's #1 hub for sharing code and collaboration with 40 million developers in GitHub, and also Microsoft Azure. You have a myriad of close to 100 platform as a service components that you can use to put together your cloud native applications. And the combination of these three will deliver DevOps for your organization. So I keep on talking about cloud native. Let me just define what cloud native is for those of you who don't know what cloud native is. So cloud native essentially is, as the name implies, is our applications that were created and born in the cloud. So imagine a scenario where you use a tool such as Visual Studio or any other of your open source tools and create your applications using code, whatever your language of choice would be, but then running these codes on containers, using orchestrators to make sure that codes work together with each other, using serverless components so you don't have to worry about sizes of virtual machines as you would do in the past, and also breaking down applications into smaller services such as microservices. On top of that, because cloud native also means this is you have a single code that has the ability to run across different platforms, ability for it to be immersive and personal, and also be intelligently data driven. Now, Azure is a turnkey delivery platform for cloud-native applications. So this is not a webinar to discuss the PaaS capabilities of Azure. I just want to put up this slide so that you can get some of the capabilities that are on Azure across compute orchestration, databases, integration. I should mention that under the databases, we now have open source managed MySQL and Postgre as part of the databases on demand that you can use as part of your application. And then for integration, we have Logic Apps, Event Grid, and so on. Now, whenever you want to run DevOps within your organization, you actually have two choices. You can continue to use Azure DevOps tools which is currently empowering thousands of enterprises across the planet to run DevOps operations for them. Or you can use exclusively GitHub, which is the home of open source software for 40 million plus users. Now, I've seen some customers go exclusively DevOps and some of them go exclusively GitHub, but I'm starting to see a combination of those two being used at the same time. So like I said, so this is the same DevOps cycle as you can see: plan, develop, deliver, and operate. And you can see here what are the typical tools that are used across each of the stages. So for plan, you have agile planning tools such as Azure boards. Develop, you have different developer tools and collaboration tools. It can be Visual Studio and GitHub if you want, or you can use your own open source developer tools, Python, authoring tools, etc. For delivery, you have CI/CD pipeline code capability, security package registry, and infrastructure as a code infrastructure. And then for operations, these you have tools that provide insights, analytics, and cloud security for your applications. Now for source control, you can do, again, two schools of thought here. If you want to stay within Azure, you can use a tool called Azure Repos, which is part of Azure DevOps, or you can use GitHub as your source control tool. For CI/CD, you can use Azure Pipelines, which is again part of Azure DevOps, or you can use GitHub Actions, which is part of GitHub. For packaging code, you can use Azure Artifacts, which is part of Azure DevOps, or you can use GitHub Packages. So again, like I said, you have a choice between using purely Azure DevOps components, or you can use purely GitHub components. But again, I've seen some customers using a combination of both. Now, the great thing about using either Azure DevOps or GitHub is you are building applications with a shared engineering team. So both Azure DevOps and GitHub organizations within Microsoft, we share the same leadership. We bring in the requirements and insights of DevOps of customers to GitHub. So we continuously get insights from our enterprise customers and then make improvements to the GitHub platform so that our GitHub guys and girls can make improvements based on our feedback from our enterprise customers. It's also standardized tooling for over 100,000 engineers from Microsoft. So we eat our own dog food, so to speak. So we use all of them internally as well. Through GitHub, we provide three things: unified authentication using your Azure AD. We provide traceability and governance. So you can plan and track work on Azure boards, which is part of Azure DevOps, and link it to GitHub. Because I don't think GitHub specifically has a quite robust planning tool, but Azure DevOps does. So that's one example of where Azure DevOps and GitHub work closely together, especially in the planning stages. Automated workflows that you have created on Azure. On Azure, you can run it on GitHub Actions, and you can even reversely run GitHub Actions for Azure. And that GitHub Actions now has native support for things such as Azure Kubernetes Service, Web Apps, and Container Registry. So essentially what this means is that whatever automations that you created for GitHub Actions will also carry on over to the PaaS platforms where you deliver code on Azure. We'd like to say that GitHub powers the future of software development. This is part of the reason why, I guess, majority of the reason why Microsoft acquired GitHub in the first place, because we have seen that the approach is, the approach to community and the concept behind GitHub is very sound and is going to be the future of software development. So it means collaboration with open source and inner source, meaning using a single as a platform such as GitHub, which traditionally has been used for developers who are from different organizations to collaborate, and use that to collaborate for your developers within your organizations as well. Securing the software supply chain and also automating workflows from code to cloud. Now, native DevOps platform is built on the Planet's code base. So you can see here on the right side, the same DevOps flow: plan, develop, deliver, operate. What we have here, what I've written down here, is what are the different tools that is part of Azure DevOps for each phase. So for plan, we have Azure boards. For develop, you have Azure repos and Azure test plans for you to do manual and automated testings. For delivery, you have Azure pipelines and Azure artifacts to do CI/CD and packaging of software respectively. And for operate, we have Azure Monitor and Security Center that allows you to monitor your applications while it is in production, as well as making sure that your applications remain secure. Now on the GitHub side, on the develop phase, this is where GitHub collaboration tools come in, as well as GitHub Actions, packages, and security are. This is where these GitHub components are used on the delivery phase. Let's talk about plan first. Plan, develop, deliver, and operate. So agile planning means it's planning, tracking, and discussing work across your team. So this means that it's end-to-end traceability. You know what each one of your members of your development teams are using. You're tracking the ideas in the development stage and keeping tabs and aligning your team members with code changes. You should be able to also gain new insights on the health and status of your projects through insights and tracking. And and because it is Agile, it should be Scrum ready. So a lot of developers are using the Scrum concept or the Scrum approach to build in Scrum boards and planning tools to help teams run sprints. And you can use Azure boards exactly to do that. All right, so after planning and continuously planning your applications, the different changes in the applications and different changes of the code, now it's time for you to develop. Now, the developer tool of choice, of course, for Microsoft is the Visual Studio, the whole suite of Visual Studio, all the way from full-blown Visual Studio to Visual Studio or VS Code. What we try to do here is that we provide an integrated developer environment from Visual Studio that interfaces directly with Azure DevOps. So this would allow us to deliver unprecedented levels of developer productivity. Create and publish repositories, managing pull requests on GitHub, and reviewing source code inside Visual Studio or VS Code. You can also use Azure DevOps tools to quickly publish and test on Azure using Azure testing tools, and also the ability to debug after deployment, or even during the deployment itself, to find and easily resolve bugs and performance issues in your cloud apps, including using minor tools such as Snapshot Debugger or IntelliTrace to track your code's execution history within the same IDE. Of course, obviously, GitHub does not have its own IDE, so GitHub in this sense would be used as a collaboration tool. Speaking of collaboration, you have two choices again. Within Azure DevOps, you can enable inner source and open source culture inside your organization. So again, like I mentioned a while ago, increasing collaboration, breaking down silos, and creating developer love by increasing their satisfaction simply because you're allowing developers to collaborate amongst themselves, sharing code and adding enhancements on their own code with one another. We're starting to see that people are using GitHub as their enterprise collaboration developer platform. And as I mentioned a while ago, GitHub has been used for years for that same purpose in the open source community. So it's the same thing, increasing collaboration, breaking down silos, and also developing higher developer satisfaction. So if you're confused at this point, I'm going through the different stages of the DevOps cycle from plan, develop, to operate, and I'm showing you screenshots of different ways of how you do it across Azure DevOps tools and also the different GitHub. Delivery means it's time for you to deliver the application itself through your standard delivery channels, most likely PaaS components such as containers or web services, whether on Azure or any other cloud service provider. So Code-to-Cloud DevOps essentially is the breakdown, as you can see here. The GitHub approach, if you will, is to code the application, build it, test it, release it, deploy, operate, monitor, and then go start with the planning process again. It's sort of an expanded view of the DevOps process that I showed you a while ago, but it's essentially the same. You can deploy anywhere, including your own data centers, on-premise, Azure, AWS, or even GCP. And GitHub becomes the home of your own code or even the world's code. So not only do you have a secure repository of your own enterprise code within GitHub, but you can also marry that with code from outside, and all of the security, accessibility, and access controls are built into GitHub to have physical or have logical separation between those two. CI/CD pipeline within DevOps allows you, using a visual tool, to accelerate development through automation. So there are two schools of thoughts in automation here. You can use a visual tool as you see here in the screenshot, or you can use scripting tools that most people most developers are actually used to derive continuous innovation and continuous deployment. It's quite easy and simple to use. It's configuration based on YAML with a host of sample workflows. It's already there in the sample workflow, so a lot of people I know use those sample workflows as basis for their CI/CD pipeline process. And there's also thousands of open source actions maintained by the community. So some of them are, so you can actually access this community source for CI/CD pipeline workflows and then expand that or change it according to your own needs. For packaging software, package storage includes multiple artifact types. You can include authentication and permissions, meaning you can store your packages which inherit permissions in the same secure environment as your source code. You can also discover both public and private packages, explore and reuse your organization's private packages alongside with public packages that are currently in GitHub. Packages that are hosted in GitHub can also include all the information that you need. That includes content, statistics, version history, and more. So here's a screenshot for those of you who haven't seen GitHub before. On the right side, you can actually see the full detailed history and insights of all packages that are provided for by your own developers within your own enterprises, or public packages that have been provided for by the larger community. Delivery via GitHub, as you can see here, can also, again, similarly, you can accelerate delivery through automation. You can use the visual tool to map out your automation flow, or you can use scripts, simple, easy to use using YAML. And again, same thing. You have a community that allows you to get in GitHub that allows you to get community contributed workflows that you can then customize for your own needs. Seems to be a repetition. So yeah, sorry, it's not a repetition. But so one of the things that you can also do here is you can now sign into Azure with your GitHub credentials and authenticate to GitHub Enterprise using Azure AD. So this is one example of the integration that we are now putting between GitHub Enterprise and also Azure, using credentials across both, especially if you're an organization that uses both platforms for DevOps. Another thing is end-to-end traceability and governance. So for example, if you've done your planning and your agile planning using Azure boards, you can link it to GitHub and then monitor your code deployed to Azure from GitHub Actions. From the operate side, one of the key capabilities of operate requires cloud security. So one of the things that we are espousing developers to use as part of their DevOps is a feature of Azure called Azure Security Center. Azure Security Center has a feature called Secure Score. Essentially, you run an internal audit of all of your applications and all of your code within your dev test environment, even your production environment on Azure, and it will come out with a score and a set of recommendations on what you can do to make sure that your security posture continues to be strengthened. You can also set security policies for subscription or management groups. That's always been a hallmark of and I dare say a standard process that you would need to do for Azure to ensure that people within groups can run a certain thing according to their access control. And then built-in threat protections for Linux, Windows, Cloud Native, and data services we have complete set of data threat protections across all of these platforms where you can choose to deploy your applications. For code security, we use vulnerability dependency insights and automated security fixes with Dependabot to make sure that all of the code that you put in from GitHub, from public sources, or even code that you in-source, are protected against or are checked against security standards. We also leverage on on the scale of Azure security to do pattern-based security analysis. It's always on with GitHub Advanced Security to scan both open source repository and your own enterprise code. There's, again, because of the community spirit of GitHub, if you will, this is integrated into the international or national vulnerability database and white source for up-to-date security information. So GitHub itself is being updated regularly through these different security sources to ensure that code that runs or are hosted within GitHub remains constantly secure. The other tool that we espouse our developers to constantly use is a part of the Azure monitoring tool called Application Insights. So once you've already deployed your code, Application Insights is used to store data or first of all, collect and then store data from the components of your application, may it be the web service, the database, the virtual machines, and the operating system until the virtual machines and everything else. And it gives you a dashboard, as you see here on the screen, that gives you deep operational insights on the way your application is performing. So some of the things that you can see here includes the number of users currently connected to your application, the max number of users, CPU utilization, database utilization, number of failed command attempts, number of successful command attempts. So your operators can actually see how your application performing while it is out in production being used by end users. And once you see a problem using application insights, then you can immediately address them quickly. Again, following the same DevOps process of planning, deploying, planning, development, and collaborating, deploying, and then operating again. Let's talk about integration. Native integration. So as I said a while ago, we are now starting to see people, for example, developing applications on Visual Studio using the Azure DevOps set of tools to operate their DevOps in combination with GitHub, so that you can use GitHub practices and also outsource open source code in combination with your own enterprise code as well, and then deploying that across Azure PaaS components such as web services, databases, and then using the Azure monitoring tools to continuously monitor the operation of your applications while it is in production. So some of the native integrations include unified authentication across using Azure Active Directory, end-to-end traceability and governance, automated workflows, and IDE integrations. If you're interested in adopting GitHub, here's some high-level guidance over here. So if you are using Azure DevOps now, you can continue to leverage on Azure DevOps, and DevOps is not going away. It's still there. And the capabilities such as of Azure boards, Azure pipelines, Azure CI/CD, and Azure packaging of software, etc. It's still there, and there are new features, and then we continue to come up with new features. You can then transition to GitHub if you want, based on the timing and depending on the need of your business. On a project by project basis, I've seen some customers adopt GitHub as their primary DevOps platform, but in combination with other capabilities in Azure. For example, Azure has more robust application monitoring capabilities as part of Azure monitoring. And I've seen customers using Azure boards as their primary planning tool for ideation for their developers, while using GitHub as their code repository and code management tool. So it's really up to you. You can do it on a per project basis. You want to start evaluating your move to your Git repositories to GitHub, and you can also start integrating Azure boards and Azure pipelines into GitHub. Get help from a Microsoft partner. We have a few partners out there that can give you the advice on how to best adopt the DevOps culture primarily within your organization before you adopt the DevOps tools or GitHub tools within your organization. And of course, Microsoft Learn and Microsoft Docs are always there to give you up-to-the-minute training and also documentation. Now, there is such a thing called GitHub Enterprise. So there's a host of other features of GitHub Enterprise compared to free GitHub. And you can see, unfortunately, I don't have a slide here that kind of differentiates between the two, but it is available on the public website. But if you are interested in getting GitHub Enterprise, it is now available as part of your Microsoft Enterprise Agreement. So for those of you who have Microsoft Enterprise Agreements, of which Visual Studio subscription is part of the Enterprise Agreement, you can actually add on GitHub Enterprise licenses on top of your EA. So to summarize, it's actually your choice. So here's an example of the whole DevOps process from planning, tracking to coding and building and testing to deploy to operate and monitor using exclusively first-party Azure DevOps and Azure DevOps tools. But you can also combine that together with open source tools, such as, for example, I've seen customers using Jenkins for build and test, Terraform for deployment, Ansible for operations, and the ELK stack for monitoring. At the end of the day, really, it's really your choice of what you want to do. So like I said in the beginning, some customers choose the purely Microsoft path by using Azure DevOps exclusively from beginning to end the entire DevOps cycle. Some customers choose to go the other way to run purely open source with GitHub. And these open source tools, Jenkins, Terraform, Ansible, ELK, and all of other open source tools are actually available as part of the Azure Marketplace, and you can run all of them on Azure. And we have several customers that run their entire DevOps and developer applications using purely open source tools running on Azure. All right, so that's all about DevOps. So I want to spend a few minutes talking about Azure DevTest. So it's quite different from DevOps. So in DevOps, we've talked about how you automate and create collaboration and create a collaboration environment within Azure so that your developers can create robust code with fast changes that you can deploy quickly and reliably. DevTest, on the other hand, talks about development and test infrastructure. Okay, so within an IT organization, you always have these people called the developers who constantly demand for resources to do things such as development, team collaboration, and dev and test. So what the typical tools that are needed by the developers at a high level is, of course, a PC or a device where you can do the development itself, running Windows or running Mac, running Visual Studio or whatever open source tools that you have. Then you have a platform for them that requires them to do collaboration, and then a set of servers where you run the development and testing. 30% is the average number of percentage of servers dedicated for development and testing. But get this, only 3 to 5% of these development testing servers are actually being used in terms of utilization. So we are actually wasting a lot of server resources by leaving them idle while we are not doing any devs or tests. Sorry for that picture. I think it's cute. Today, developers find that provisioning your infrastructure takes too long. So how many of you have ever complained to IT that says that I needed my dev environment 2 weeks ago? I already made the request and it's still not there. Configuration of these dev and test environments actually take time. IT will come back to you and say, oh, wait a minute, we need to apply certain policies and make sure that you're not allowed to do certain things, but only allowed to do certain things. Costs are out of control because sometimes developers ask for too much but end up underutilizing most of it, and usage is really not that predictable. So this is the reason why one of the most popular ways of using Azure by even for governments and even for finance and banking sectors, which are traditionally very, shall we say, not immediately diving into using the public cloud, is development and testing. So imagine a scenario where you are using Azure to get to 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 get quick developer environments that are already pre-configured as far as security is concerned for your development team. This increases your agility. This increases your savings because you're not overusing or under sorry not overusing but underusing resources that are given to you. You are provisioned the exact compute, storage, and network resources. As at the same time, I'm going to talk more about this later on, but if you declare that you're going to use any of these resources for dev and test, you will actually get a discount. And then finally, you can be in control of different development and test environments in the cloud. So what we have in Azure today is that we have a constant um, uh, shall we say, permanent dev test offer. Essentially, what this means is that if you want to create a dev test environment on Azure that runs Windows, SQL Server, Azure DevOps, GitHub, and all of these other tools that I've just spoken about, you will get the best rates. So cheaper compared to that of AWS or anybody else. Deep discounts on developing and testing across a broad range of services, because we will not charge you for software on virtual machines, Azure SQL Database, or app services. And even you can even save your hybrid benefits for production workloads. So dev test images are available on Windows 10, and you also get one bill. So you have a unified administrator using Azure Portal. For those of you who are already existing Azure customers, you don't have to worry about that. Your Azure monetary commitment also covers both production and dev test workloads. Speaking about discounts, this is what I meant. If you were to use, for example, Windows Server, SQL Server, and BizTalk, uh, a D-series virtual machine that runs BizTalk, which runs Windows Server, you will normally pay these amounts per month: 137, 1,232, 487. Take a look at the rates that you're going to pay if you take this offer. So for the SQL Server, so similarly sized SQL Server Enterprise D2 V3 version machines, instead of paying 1,200, you're paying $70 a month. Again, this is something that you can easily provision in the Azure portal by just saying that, yes, this is going to be for dev test. Your discounts will be, yes, you can see here. You even further get service savings if you reserve that across 1 year. So using the Windows Server D3 example, you will get a 62% discount. Even further discounts if you reserve it for 3 years. Here's another example for SQL databases. So if you use managed SQL database service for your applications, for your dev test, not for production, for dev test. For production rates, you still continue to pay the amounts that you see there on top. But for dev test, you get on average a 55% discount. Again, same concept. If you reserve for 1 year, you will get further discount. Or if you reserve for 3 years, your discounts escalate to 73% in this example. The discount will vary depending on the region and the type of service and the type of sub-model of the service that you're going to get. So DevTest Labs, if you go to aka.ms/Azure DevTest Labs, we made it even easier for your IT administrator to give you developers a pre-configured set of components in a dev and test environment. So fast provisioning, automation, and self-service, and cost controls and governance. So think of Dev Test Labs. If I was your IT administrator, I would give you developers a Dev Test Lab environment from Azure Dev Test Lab that is self-contained and is logically separated from production. So all the policies there that would apply to you as developers will be there, and I am also in control of your costs because I don't really want my developers to, overrun their costs, and I don't want to end up paying a lot. If I'm the IT administrator, I want to be able to effectively manage my Azure costs across production and development. So also as part of the Dev Test Lab is freedom, in a sense that developers can now do self-service. You can provision your own environment. There's cost control that's built in. So for example, developers are not going to be able to provision anything higher than what is budgeted for them. And also you have full visibility of your project costs. It can include pre-provisioned environments that you've already set up as part of templates, that is part of Dev Test Labs that you can easily configure for yourself. If you are a developer, you can immediately request an environment and start working it immediately. So you can go through a whole workflow approval process, or you can just simply do self-service and you don't need IT's help anymore. You just simply make the request and then those services will now be available for you. The great thing about creating a template, if we do this properly, your IT administrator and also your developer head would create or decide upon what the dev test template would look like in terms of environment, security, sizes of virtual machines, the types of services that you will get. So once you've already created this template, you can in fact fork this template and create several templates. For example, the people who do core banking projects will have a dev test lab that's based on template A. People who do back-end applications for the bank will have a dev test environment that's based on template B. The good thing about this is that once you create the templates, you can share it and you can simplify your testing environment provisioning. You can definitely integrate this to your existing tool chain. So whether you're using Azure DevOps tools, GitHub, or even using open source tools such as Jenkins, Chef, Puppet, Eclipse, Ansible, and so on. The dev test labs can definitely connect to all of these preferred tools that you have within your toolchain. So if you want to learn more, you can go to aka.ms/Azure DevTest pricing, or you can set up an EA DevTest discussion, a subscription for a walkthrough. This is actually a video. This second aka.ms link is actually a video. I believe it's in YouTube that shows you how to create your own DevTest subscriptions as long as your Azure administrator has allowed you to do such things. All right, now if you are an enterprise customer, you would have something called an Azure monetary commitment. So your IT decision makers have decided to pay Microsoft upfront for usage of Azure. Now it's quite straightforward, but you have to remember that you'd have to think about dividing your environment, if you will, within production and dev test. Some customers I've seen, and I think it's pretty smart, to divide the subscriptions. So one subscription for production and one subscription for dev test. Having two different environments or even subscriptions would be better in a sense of management, because you can you end up you can manage to control and say, if it's, and say for example, I want to use the enterprise dev test offer and take advantage of the discounts on this subscription where I run exclusively dev test workloads. And then the workloads that are here are exclusively for dev test for your developer environments, while on the other side everything is for production. All right, so we are close to the end of the webinar, so I just wanted to round this up again by reviewing and looking at the dev test process. Plan, develop, deliver, and operate. And underlying to that is the process or capability for your developers to collaborate, enabled through workflow, while ensuring security and compliance and continuous improvement. You have different set of Azure DevOps tools like Azure Dev Boards, Azure repos, test plans, pipelines, and artifacts, monitor and security center across each one. And then GitHub can be used to facilitate collaboration when you do the develop phase. GitHub also has certain tools to help you deliver your code, and then you marry that together with capabilities that are in Azure. So so you've seen a number of examples. I hope that was clear that you can combine both DevOps and GitHub for your DevOps environment. So that's the end of our webinar today. I just want to make sure that you get access to these resources. So you still can get your Azure free account. You can go to azure.com/free, enter your credit card information. Don't worry, we're not going to charge your credit card. What you will get is a $200 credit and 12 months usage of a lot of free services. As long as you don't go over the limits of these different services, such as 750 hours of Linux virtual machine, or Linux VM, or 250 gigabytes of SQL database, your $200 remains intact. The only time your $200 gets debited or gets subtracted from is when you start going over the service limits over here. You also get access to a lot more services on Azure, and these are all free. It doesn't get charged against your $200. So literally, when you use your Azure free account, you can build a lot of you can actually start building a lot of stuff without paying a single cent. But if you do start going over certain limits, then you will get a friendly email from Microsoft or a message in the Azure portal saying that your $200 is now almost close to zero. So therefore, you got to either do something about it or start charging your credit card with actual usage. Online learning is available. You can go to Microsoft Learn. So this is the full URL here. But if you don't remember that, you can just search for Microsoft Learn. Select your role. What type of role are you performing right now? Are you an administrator, AI engineer, data engineer, or data scientist? Once you make a selection, there will be online courses that will be made available to you in accordance to the role that you have just selected. And these are curated training, which includes video training, hands-on training, code training, and so on and so forth. So which will help you prepare for your job, and it will even help you prepare to pass certification exams. There's a specific school for AI called aischool.microsoft.com. So this is where you can learn how to build chatbots using our conversational AI framework and build applications that can interact with the world around you using cognitive services, applications that can, for example, do voice recognition, image recognition, picture recognition, video recognition, and so on. So all of that is in aischool.microsoft.com. And complete documentation is on docs.microsoft.com. Just click on the Azure link right here and then do a search. All of the documentation that you would require, including code samples, tips on architecture diagrams, or just to get you started on using Azure services, are all there in Microsoft Docs. Okay, so there we go. We are towards the end of our webinar. I just wanted to remind everyone about the next set of webinars that are coming next. You see the dates there in front of you, and if you go to aka.ms/msfy20 webinars, you can see the next webinars that are coming, and you can also register from that website as well. Thank you very much, ladies and gentlemen, for joining me. I have been Hearn. This has been Hearn, your Azure Business Lead from Microsoft Philippines. Thank you very much for listening in. For those of you who entered your question, thank you very much for your questions. Hope to see you soon in our future webinars and our future events. Bye.